Let's take a look at our first NJSLA question. A class of 25 students share a class set of 100 markers. On a day with 5 students absent, which statement is true? So for each of these questions on the NJSLA, it's important that you read them carefully, because at first glance of this problem, we might use 25 students, but instead 5 students were absent, so what number should we be using? Yes, 20 students. Now 20 students are sharing 100 markers. If we want to find out how many markers each student gets, which operation would we use? Multiplication, division, addition, or subtraction? Okay, there are 100 markers. There are 20 students. In order to find out how many markers each student would get, we would divide. Okay, this particular problem is a non-calculator part. I got these problems from the practice tests of the NJSLA on the New Jersey State Department of Education. So that's where these problems came from. If we take 100 divided by 20, to make it easier for ourselves, because we don't have a calculator, there's a 0 here and a 0 here. By just crossing out these zeros is essentially the same as dividing by 10, the numerator and the denominator. 10 divided by 2, now that's a much easier division problem. 10 divided by 2 is 5. Therefore, there are 5 markers for each student. For every one student, there are 5 markers. Therefore, the answer is D. Let's look at the second one. The area of a rectangular patio is 5 5/8 square yards, and its length is 1 1/2 yards. What is the patio's width in yards? A lot of these tests, these standardized tests, ask for area and perimeter. So it's important that you know how to find the area of a rectangle. The formula for the area of a rectangle is what? Area is equal to length times width. We're given the area. They are telling us that the area is 5 5/8 square yards. What else are we given here in this problem? Yeah, the length is 1 1/2 yards. And our unknown, we are looking for our width, which is W. Okay, I'm going to just erase this so I have a little bit more room. When you have a problem, now these are called a mixed number. It's called a mixed number because you have a whole number and a fraction. When you have mixed numbers and you are required to divide or multiply them, you want to convert them to an improper fraction. So what we're going to do is we're going to change these mixed numbers to improper fractions in order to finish this problem. So 5 5/8, who remembers how to change a mixed number to an improper fraction? We take 5 times 8, you multiply that together, then we add 5. So we're going around. 5 times 8 is 40. 40 plus 5 is 45, so we have 45 over 8. And 1 1/2, please convert that to an improper fraction. 1 1/2, 1 times 2, multiply that together, we get 2. Add the 1, so we have 3 over 2. I'm going to put this in parentheses. it's still, what is the operation between the L, the length, and 3/2? The operation is multiplication. Parentheses together indicates multiplication. I want to get L by itself. When I have multiplication, what is the inverse operation of multiplication? Yes, division. Okay, so I need to divide by 3/2. When we divide by a fraction, it's the same as multiplying by its what? Reciprocal. Okay, good. What is the reciprocal of 3/2? The reciprocal of 3/2 is 2/3. Okay, so why am I multiplying it by 2/3? When I multiply a fraction by its reciprocal, look what happens. They cancel out. So we're just left with that L. Okay, I'm going to put it over here because I kind of ran out of room. Whatever I do to one side of an equation, sometimes you'll see your teacher put a line through the equal sign, and it's showing you that whatever you do on one side, you have to do to the other. Okay, good. So we're going to multiply this by 2/3. When I do that, sometimes there's a shortcut teachers like to use. I know I like to use it, where I say, okay, I have a 2 here and an 8 here. Let me get a different color to show you. 2 goes into itself, and 2 goes into 8 how many times? What is 8 divided by 2? Okay, 4. 3 goes into itself once, and then we can cross out the 45 because 3 is divisible by 45 by 15. Okay, so when I rewrite this, 1 times 15 is 15. 1 times 4 is 4. So my answer as an improper fraction is 15 over 4. However, as you can see from these choices, they're mixed numbers. So we're going to change 15 over 4 to a mixed number. 4 goes into 15 how many times? 3. And what are we left with? Well, we know 4 times 3 is 12. 12 from 15 is 3, so that is my numerator, and then my denominator is always the same as this denominator. So your answer, final answer, is 3 3/4. Okay, what I'd like you to do is you're going to pause this video and you're going to try the next 2 problems on your own. All right, coming back, the first try it is just like the number 1 up here. Okay, so let's take a look. A class of 24 students shares a set of 120 erasers. In this case, it's erasers. Let me just erase this so you guys can see the word problem. And on the day that, on this particular day, 4 students are absent. So how many students are we dealing with? Okay, 20. Good. Because 24 minus 4 is 20. So we have 20 students, and they are sharing 120 erasers. Again, similar to what we had in number 1, we want to figure out how many erasers for each student. So what operation should we do? Multiplication, division, addition, or subtraction. Okay, so to figure out how many erasers one student gets, we are going to divide. Again, we can say that I can just cross out these zeros and take 12 divided by 2, which is, so we have 6 erasers for every one student, for each student. So your answer here is D. Number 2, the area of a rectangular garden is 9 3/8 square meters, and its length is 2 1/2. Actually, this would be the length, the other one would be the width. So we're trying to figure out the width. What formula is the area for a rectangle? The area is length times width, which everyone should know. I'm going to plug in. What would I plug in for my area? Well, they're telling us that it's 9 3/8. So we're going to plug that in for A. They do tell us the width, don't they? So what are we going to put in for L? 2 1/2. Good. And our W is our unknown. Okay, in order to do anything, before we add, subtract, divide, multiply, whatever you need to do in this problem, what should we do to these fractions? Yes, change them to improper fractions. Okay, to change them into improper fractions, we take 9 times 8, which is 72, plus 3. We have the 3 up here, which is a 75. That's going to be over, oops, I ran out of room. That's 75 over 8. Our denominators are always the same. 2 1/2, 2 times 2 is 4, plus 1 is 5. And that's going to be 5 over 2 times W. Now, I need to get W by itself. I have a 5 over 2. What did we do in number 2 above? How do we get W by itself? What do we need to multiply to get rid of that 5/2? Who remembers? Yes, we're going to multiply by the reciprocal. What is the reciprocal of 5/2? 2 over 5. Good. When I do this, these numbers cancel out. The 5s cancel out because one's in the numerator, one's in the denominator. The 2's cancel out for the same reason. Now our W is by itself. That was our goal. But we know that in math, we have to follow rules, and the rules say whatever you multiply on one side, you do on the other. So we have to multiply by the same exact thing. Here we multiplied by 2 over 5, 2/5. We're going to multiply by 2/5 here. Remember I showed you that method of canceling out to make your life easier. You're going to do the same thing. We'll change colors. Let's try blue. 2 goes into itself once. 2 goes into 8 how many times? What is 8 divided by 2? 4. 5 goes into itself once. 75 divided by 5 is what? 15. Remember, this is a non-calculator part. Then you take what's left and multiply across. 1 times 15 is 15. 1 times 4 is 4. Our answer is 15 over 4. However, we have to change that to an improper fraction. Okay, how did we do that before? Why does this problem look exactly the same? Wow, very similar. Well, the answer was 15 over 4 before. This one is the same. We take 15 divided by 4, which is 3. 3 times 4 is 12. 12 from 15 has a 3 as a remainder. That goes in the numerator, and your numbers in the denominator are always the same. Okay, so this is our final answer.